So I'm in NODMA at the moment, and within NODMA, this is Rebecca's classroom. So you can log into Rebecca's platform of NODMA, and at the top, then you can see what it will show you when you first go in is these three different areas, and you can go directly to the classroom area, which then enables you to have a look at all the books that will give you an overview of the different topics. And the main one that we're going to look at now is this one, which is light energy, which you can use for teaching about light. And you can go directly to read, and this can be done through workstations, or you can give them the logins from year 3, which I've attached to the email, and they can go directly into those logins. You can assign each student a login, or you can do it in class with like the interactive whiteboard, or as I mentioned before, as workstations where they work in pairs, or if they work in a group of 4 or 5 even, because the resources are quite large, and the book focuses really on doing like blended learning. So you've got here, for example, properties of light. So you could, for example, use this in combination with the STEM channel that we looked at before, which is, this one here, which is basically the, so you could go through this, you could go through 1 or 2, and then you could get them to do the project exercises, which are in NODMA. So the project exercises are, for example, you've learned that light is a form of energy that we can see. It exists in the form of electromagnetic waves. Okay, so let's explore this. And it goes into what these electromagnetic waves are. Light waves are radiated to the earth from the sun, and the sun is our greatest source of light energy. So you can ask them if they want to find out more about photosynthesis, or if they know about photosynthesis. We do have another book which is about photosynthesis in this resource, so you can also connect to that book as well, or you can connect to the actual STEMWerkz channel, because that's also got a lot about photosynthesis. You just need to type it in there, and then and go into it there. So going back to NODMA, just to keep on topic for this, then there are a couple of questions at the left-hand side that you see there. So how is light energy transformed in this process? You can ask the class that question, and do a kind of question and answer idea, or you can get them to discuss that in pairs if they like. But also, what is the word equation for the transformation during light during photosynthesis? That is probably a bit too high for them. So that's more like the level which is 11 plus. So maybe that was probably not the best for them. But you could maybe like hint towards that, and that's something that they can learn later, or if they want to go and investigate that as a research question that they want to ask their parents, for example. These are all kind of extension activities that you could get them to do. You could also, if you've already covered photosynthesis, I'm not sure if you've covered that in the curriculum yet, but you can ask them, what experiments have you done before about photosynthesis, or do you know what photosynthesis is? If they're not even sure what that is, then that's no problem, because they can go to this video, and then you can also take it outside. So I know that you mentioned in our meeting today that you were concerned that they were just watching TV, and it was kind of like, oh, okay, but the idea is to have short spaces of time where they see these resources, but then they can go off outside, or they can, for homework, then to look at the moment, one of the things that I love to do right now is go out into nature and find out which plants are blooming, and see if I can guess the trees and the plants by their buds. And it's actually really hard to know what they are when they're tightly in the bud. but it's a fun kind of exploratory activity that is stimulated by this resource. So the idea is not like this is a standalone resource and then that's it and it's finished, it's over, the class is over. The idea is that these are resources that stimulate their imagination, that stimulate their creativity and their questioning and inquiry, and they get then to go out into the world, into the garden, and test and look and observe so that they can apply that knowledge. So I'm just going to show you quickly what this is. And
another plant, and it grows out of it instead of you. What questions do you have about this growth of these leaves and light energy?
so that was a really, I thought it was really kind of good way of dealing with it, because it's quite short and it gives like the students, you know, you could pair them up with each other and say, what did you observe about the way that the leaves were growing? Where do you think the light is coming from? What kind of light does it need? What kind of conditions does it need? There's all sorts of questions that even the students can actually create the questions themselves. And then you can like go around and say, you know, is this an interesting question to ask? And, you know, you could come then together back as a group and then say, okay, what were your questions? And then, you know, they might even be interested to, you know, write those questions down or ask the other team questions. So, you know, again, don't see this as like a standalone resource. It's a stimulus to create what you're already doing in class, which it sounds like you're doing brilliantly, like with the 3D activities and big ideas in science. So use that as a kind of stimulus for the in-class inquiry or the outside in the garden inquiry and observation. Okay, so this goes into a little bit more of how light travels. So what evidence is there that light travels in a straight line? Try the following experiment. So as we talked about today, then you've already done this like with dictionaries. So this is just another way that they could try it. So the image below shows you what you would see looking through a hose. When the hose is straight, you can clearly see the light bulb. Now bend the hose by dragging the eye up or down, and can you see the bulb? So, I mean, you don't have to obviously do this with bulbs. It can be, as you said, you know, with like with a hose, you don't have to do it with a hose. You can do it with dictionaries. And, you know, the idea is that if they can also think about where else might they see this kind of bending of light. So if they could think about, have they seen it, you know, at home, whereabouts have they seen it at home, just, you know, or to get them to think of, you know, another experiment that they would use in order to bend the light, or what happens when it's in water, or different materials, and what happens when it passes through different materials. And that can then, you know, be supplemented with going back to the STEMWerkz channel and exploring all the different resources here. And it goes on to the related paths, of course. You know, we talked about how Steam Valley had the campfire bit. So that's also in this particular resource as well. You can also get them to look at things like reflection. So the mirrors on the wall, and, you know, putting the light up against the mirror and what happens when that happens. Or even working with crystals and seeing, I mean, that's one of my favorite with primary school teachers, is looking at the way in which, you know, the light passes through crystals. Some of them may have that at home. I know my mother hangs crystals and she likes to see the way that the light changes and reflects. So the idea again is to not, you know, just get them to be like completely tunnel vision into the digital resource, but to use the digital resource as an inspiration for them to come out, as you mentioned, doing all the 3D work and the work in class and the work with, you know, actual materials. With the mirror thing, then that's great. They can use the mirrors at home. You can ask them to go home and experiment with the mirror, and then for them to come back, and you can like this resource looks at all the kinds of mirror activities. You know, you can look at that, but it doesn't end there. Then you go back into the home and use the mirror, and then come back and see how it's different. So it's really about like switching between this and reality, or this and the kind of real world, not always being inside the resource. So yeah, what I like about NODMA is that it does, you know, ask you, okay, what did you conclude from the experiment? So it doesn't just leave you there. It asks, you know, the students to come up with their own conclusions. So it gets them to extrapolate knowledge. It asks them to understand their own observations, but also come to a conclusion about what those observations might mean, and how that can be applied in different ways in the real world. Okay, so this is just another kind of project that they might be able to do. Sorry, it's a bit slow at the moment. Okay, I'm sorry, I think it's probably because of my computer, but you can actually click on this and you will actually find that it hits, and then it scores points depending on what it hits. So this can actually lead to a couple of things about reflection. I'm sorry. Okay, sorry, that's the one that I wanted to go back to. So the idea is that you try your hand of getting the ball to hit the most number of bricks in 1 minute. And there are 2 different levels to the game, so they can try it with each other, or they can try it as a class. And you move the paddle with a smooth, rough surface along the bottom of the screen, and then repel the ball towards the bricks. And the idea is that you try and destroy as many bricks as you can. So yeah, I mean, it's actually just a kind of fun game, but you know, it's up to you if you want to play it as a group, or as maybe maybe if they want to do it at home, you could also get them to play it at home. The last one that I wanted to come to was basically how light travels through different materials. I love this one because, you know, the idea is that they can also try this at home through observation.
Try this with your own objects. Take a look. Is that translucent, transparent, or opaque? How much light gets through? Why do you think this is so?
So that's, you know, as we talked about in the meeting today, they can try this in the school. They can experiment like with their pencil cases, with their hands. You know, one of my favorite when I was younger was looking at, you know, wow, your hand gets red and it becomes, you know, you can actually even sort of see inside a little bit, you know. And I think that gets the students really excited about doing this kind of experiment. Okay, so moving on, this is talking a little bit about you know, how you can observe it within real life, within, you know, how it reflects upon the water. And again, that goes back to the idea about reflection, which is, goes into the whole mirror aspect. So you can like switch between the STEMWerkz channel and NODMA itself. You can have them both open, for example, on, if you have one of those interactive whiteboards, or, you can get them to log in their own workstations, and you can have both of them open and have them, switch between the two, or you can guide them to switch between the two if you don't want them to work, fully autonomously. And it talks a little bit about the ways in which there is reflection on a regular sort of smooth surface, and what happens, when there is somehow a regular surface. So again, this is a little experiment that they can do in a darkened room. Place materials such as a mirror, a spoon, unpolished wood, paper, cardboard next to a wall, and it's the one that you actually just saw. So it's just going over really what was done before, but it gives it a bit more of a guided sort of teacher's way of saying, do this, do that, do that. So I'm just going to end it there, but I hope that gives a little bit more of an idea of how you can also use NODMA in combination with the STEMWerkz channel, as we talked about today, because I know that one of the needs that you specifically said is like how to bring it out so that they can, as you're already using the 3D projects within the class, what are the kind of projects that these resources can bring them to. So I would recommend that you do at least have a look at NODMA, just also as an extra way to do those experiments, and then STEMWerkz is really to do the little short learning objects that are very good for giving the students a short idea of what the scientific concept can do, and then you take it and apply that within a project. And if you need that kind of help with what the project could be, then NODMA is full of ideas and examples of those kinds of interactive projects in class. So I hope that helps, and do let me know if you have any questions going forward. Okay, thank you.